During this video, we are going to review the electronic configuration for ions. First of all, we have to remember what is an ion. An ion is an atom that has a charge, okay, or that has been electrically charged and therefore can react. There are two types of ions. We have cations, which are the ones that have a positive charge because they have lost electrons or they have less electrons, and an anion, which are atoms that have a negative charge because they have gained electrons. Just remember what we learned previously. Electrons are the ones that have a negative charge. Therefore, we are saying that are going to be positive because they have less electrons. Okay, that's why the cation has less electrons, so therefore has lost a charge. Has a positive charge because it has lost electrons. And the anion is the one that has a negative charge because it has gained electrons. So it's a little bit confusing because you may think that if we are losing, it will be negative. But in this case, since we are losing negative charge, it's going to become more positive, okay? Just remembering, cation are the ones that have a positive charge, anion are the ones that have a negative charge, okay? So what happens with the electronic configuration when they have a charge? First of all, we have to remember a little bit about the octet rule. Remember that all the atoms, they want or they are willing to have 8 electrons in the last level of energy. Remember why we saw valence shell and valence electrons? When they have 8 electrons in the last level of energy, they are going to be stable, okay? So depending on how many electrons they have in the valence shell will be the ability or the possibility that they have of forming cations and anions. In the periodic table, we have a pattern depending on the group in which they are located. Remember that the group tells you, well, the valence electrons that you have will tell you the group in which the element is located. So all the elements that you have in group 1A will have 1 valence electrons. Therefore, since they have 1 electron in the last level of energy, they are going to be willing to remove or to form cations because they are willing to not have that electron in the last level of energy, because it's easier to give 1 electron than to accept 7 electrons in order to form the octet, okay? In group 2A will be something similar. They have 2 electrons in the last level of energy. Therefore, it's easier to get rid of the last 2 electrons that we have in the last level of energy instead of searching for 6 and get the octet that we are willing, okay? Transition elements are particular because they can form multiple cations, okay? Some of them, they can form +2, +3, depends on the element that is right next to it. And we will see it by the time that we make compounds and that we learn the nomenclature rules, okay? But for the representatives, if we go to the group 3A, okay, in that specific group, we have aluminum, for example, it will be forming cations +3, because it's easier to get rid of 3 instead of searching 5 in order to get the octet, okay? So we have a pattern, +1, +2, +3, okay? Elements in group 4A, except of tin and lead, they are going to be forming either cations or anions because they are going to be having ±4, because for them it's going to be the same to get rid of the 4 electrons that they have in the last level of energy or to search for 4 electrons in order to get the octet, okay? By the time that we make compounds, we will see which is the value that they will take, okay? But these are positive or -4. Starting from group 5A, things get a little bit different, okay? Why? Because in this case, since we have more electrons in the last level of energy, it will be easier to search for electrons instead of get rid of what we already have in the last level of energy. That's why in level 5, they are going to be forming anions, okay, with negative charge. And in this case, for example, will be -3, -2, and -1. Because, for example, elements in group 7, since they have 7 electrons in the last level of energy, for them will be easier to search for 1 electron instead of get rid of the 7 electrons that they have in the last level of energy. Remember that all of this, it's done due to the fact that the elements that we have in group 8A, they have 8 electrons in the last level of energy and they are stable. So all the elements that we have in the periodic table, they are searching for having 8 electrons in the last level of energy in order to gain the stability that the noble gases have, okay? And why is this important? Because we will see that when they ask us for a specific electronic configuration for elements, we will see that some of them, they will ask us for the cations or for the anions, okay? So going back to the main important thing in this video, what do we do if they ask us for the electronic configuration of an ion? Okay, first of all, what we have to do is we have to make the electronic configuration of the neutral atom, okay? Let me just change this, okay? If the ion is a cation, what we have to do is we have to subtract the charge to the number of electrons. If the ion is an anion, what we have to do is we have to add the charge to the number of electrons. Okay, so for aluminum, which has an atomic number of 13, first of all, we have to make the electronic configuration. So it's, let me just change the color to that. So it will be 1. Why do I have arrows here? Let me just erase it. Okay, so we have 1s2, 2s2, 2p. Okay, we already have 4, so we have to get 13. So if I have 6, will be 6, 8, 10. We'll still have the chance to switch to the next level. So then we will have 3s. So it will be 6, 8, 10, 3s2. Okay, let me write it too. And then is 3p1. Okay, this is the electronic configuration for aluminum. Okay, if we sum the exponents, as we know, that we must get 13 that we have in the atomic numbers: 6, 8, 10, 12, and 13. Okay, since in this example they are asking us for the cation of aluminum that has a positive 3 charge, what we have to do is, as it says there, if the ion is a cation, what we have to do is we have to subtract the charge to the number of electrons. So since this is a cation, what we have to do is we have to subtract the charge that we have. In this example, they are asking us for the cation +3. So I have to subtract the last 3 electrons that we have in the electronic configuration. So what this means is that I will remove the last 3 electrons. So the electronic configuration for the cation of aluminum +3 will be what we have left: 1s2, 2s2, 2p6. Always when we are doing electronic configuration for cations or anions, the sum of the electrons in the highest energy levels must be equal to 8, because when we are forming cations and anions, what we are willing to have is to have 8 electrons in the last level of energy. As in here, we have the highest energy level, which is 2. If we sum the exponents, we have the 8. Okay, let's make another one. We have to make the anion of sulfur -2. Okay, so first of all, what we have to make is the electronic configuration for sulfur. So we have 1s2, 2s2, 2p6, 3s2, 3p, 6, 8, 12. C, and here will be 4. Okay, just let's see if it is 4. The sum of the exponents must be, in this case, 16. We have 12 is not 4. It's what? Okay, we have 6, 8, 10, 12. And how many do we have missing in order to get 16? 12, 13, 14, 15, 16. It was 3 before. Okay. There we are. So this is the electronic configuration for sulfur, which has an atomic number of 16. Since we are searching for the electronic configuration for the anion with a negative charge of 2, what we have to do is we have to add the charge. Remember, if it is positive, we subtract it. If it is negative, we add it. So what we have to do is we have to add this charge in the last sublevel of energy. Okay, so this means that these 2 electrons that I have in my charge, I will add it to the last sublevel of energy. So now the electronic configuration for the anion of -2 of sulfur will be 1s2, 2s2, 2p6, 3s2, 3p, and instead of 4, I'm gonna be writing a 6. Why 6? Because I have to add this 2 to the 4, okay? And as I told you previously, the sum of my exponents in the highest energy level when we are doing electronic configuration for cations and anions has to be 8, as we have it here, in which 6 plus 2 give us the 8.